Okay, so we're going to get started here again. If everybody could get back into their seats, we're going to get started here. I'm not sure if I went through this slide before we took a break, or if I did or if I didn't. So I'm going to quickly run through this slide again. This is a picture of a mitochondria, and mitochondria are little nano machines that are in each one of your cells. And they're like the powerhouse of the cell. They produce what's called ATP, and that are little packets of energy that run your cells. So when you need energy for some kind of process, this is what produces it. And this is important because every chemical reaction in your body is simply an exchange of electrons. You're moving electrons back and forth, and you're sharing them between molecules. So if you're removing a molecule, then that's what's called oxidation. If you're adding if you're losing an electron, that's what's called oxidation. If you're adding an electron in a reaction, that's called reduction. And we're primarily concerned with oxidation, with losing electrons, because when you have these chemical reactions in your body, sometimes those electrons escape into the cell. And it's kind of like when you have a campfire and you have little embers that escape from the campfire, and they can go someplace else and cause damage. Well, those electrons in your cell can go somewhere else in the cell and cause damage, and that's called oxidative damage. So free radicals are also what that is called, those electrons that escape. And what we want to do is we want to control that as best we can, because those can cause disease, those free radicals, and that oxidation can cause disease. And so what helps with preventing or controlling oxidative damage and free radicals? Well, it's antioxidants. And antioxidants primarily are in fruits and vegetables, and that's why fruits and vegetables are so important. That's because they contain antioxidants. And the antioxidants in fruits and vegetables are doing the same thing in the fruit and the vegetable that they're doing in you. They're controlling oxidative damage primarily from the sun. So antioxidants are close to the skin most of the time of the fruit of the vegetable, because that's where most of that damage occurs from the sun. And in general, this doesn't always hold true, but in general, a thinner skinned fruit or vegetable will have more antioxidants because it needs more protection. A thicker skinned will have less because the skin kind of protects it from the sun. Okay, now we're going to talk about fats. So fats are very important. We don't think about them too much, but they're very important. And because they provide for insulation, they're very important in the cell wall integrity. And so cells communicate with each other. And if the cell wall is not in good shape, then those cells can't communicate, and then systems can break down. Cells or fats help to absorb vitamins A, D, E, and K, because A, D, E, and K are fat-soluble vitamins, and fats provide help with communication, as I said, energy. They give us energy, and when you have toxins, that's where they're stored. If your body can't eliminate them, then it'll store it inside the fat cell. There are three basic types of fats: saturated, unsaturated, and trans fats. Now, trans fats, hopefully you know by now that those are not good for you at all. They're trying to eliminate those, but trans fats are produced by man. They're produced in chemical factories and food processing plants, and they are not good. They're not natural, and they mess up transactions in they mess up chemical reactions between fats in your body. So we're not going to talk too much about trans fats, because you should know by now just to eliminate trans fats, and you can look on the label and make sure there aren't any. So we're going to talk about saturated and unsaturated, particularly the omega-3s and the omega-6s. You can think of fats as like a dining room table with chairs around it. The table are carbon atoms and the chairs are hydrogen atoms. And so the chairs surround the carbon atoms, and if all the chairs are there, then that's a saturated fat. If one of the chairs is missing, that's a monounsaturated fat, and if a lot of those hydrogen atoms or those chairs are missing, that's a polyunsaturated fat. So saturated fats are more stable because those chairs are all there. It won't react as much to other chemicals. And polyunsaturated fats, because there are empty spots there that other chemicals can fit in, they are less stable, but that doesn't mean they're bad for you, because sometimes you need fats like that to interact with other chemicals. So this shows the omega-3s on the left side and the omega-6s on the right side, and don't freak out over this, this slide, because there's only a few important things on this slide. First of all, when you eat an omega-3 fatty acid and you're getting it from a plant source, it's called linoleic acid up at the top there, right under omega-3 family. And that goes through a set of chemical reactions here, and it comes down and it eventually produces EPA and DHA. So this happens inside your body, and but it's the EPA and the DHA that reduce inflammation, and that's very important. That's when you supplement with omega-3 fatty acids, that's what you're supplementing with, is EPA and DHA. And this reaction is not very efficient. It doesn't work very well in your body. It's you know, people debate on how efficient it is, but most people say 9% of the linoleic acid will get converted into EPA or DHA. Omega-6s, they're more inflammatory, and when you eat an omega-6, that's linoleic acid up here, and that gets converted in your body. And here at arachidonic acid is inflammatory. And so what the type of fat that you eat can depend on whether it's inflammatory or not. And we want a ratio of about 4 omega-6s for every 1 omega-3. That's what most people say. Some say 6 to 3, but most people say 4 to 1 if you can. And the standard American diet is about 25 to 1, if you can believe that. It's very off. So you might say, well, why don't we just eliminate omega-6s and don't eat those at all? Maybe like trans fats, don't eat them. Well, they're not necessarily bad, just because they're, sometimes you need inflammation in your body. If you have a cut, you need inflammation. If you damage tissue, that's the inflammatory process is what heals your body sometimes. So it gets out of control when you have too many omega-6s. Okay, and this is basically the same chart, only it's flipped. On the right side now are the omega-3s over here, and these are the omega-6s, but this is basically the same chart. And the reason I put this one up here is because it shows the blocking factors to make that process less efficient from converting those fats into DHA and EPA. So the blocking factors you can see are things that are not good. Alcohol, diets high in cholesterol, saturated fats, sugars, trans fats. And so the enhancing factors are things that you get from good nutrition: vitamin B6, niacin, zinc, magnesium, selenium. So this slide shows different types of fat that you can get through the diet on the left-hand side there. Now, what this chart shows is that each fat has saturated fat, polyunsaturated fat, and monounsaturated fat. So, for instance, canola oil at the top, it has 7 grams of of saturated fat in it. And if you look on the all the way on the right, it has 62 grams of oleic acid in it, which is a monounsaturated fat. So we want to keep, it doesn't mean that it's good or bad. It just means that it is highest in monounsaturated fat. So it would be a fairly good fat because it only has one share missing. So it's fairly stable. And if you look on the number right after the blue here, the 9 or the 7 or the 1 here, that is the omega-3. And the omega-6 is the blue. So you can see that canola oil is relatively high compared with the rest of them in omega-3, with the exception of flaxseed oil. Flaxseed oil is very high in omega-3, but remember, you're only going to get about a 9% conversion rate on that. If you want to increase your omega-3s, which is a good idea, you really need to supplement, unless you're going to eat salmon 2 times a week, 3 times a week. So it's kind of hard to get omega-3s at the level that you should be getting them. That is one thing that you probably want to supplement with, is omega-3s. You can see coconut oil down here, very high in saturated fat. Butter, very high in saturated fat. So those are fats that would be better for cooking with because they're much more stable. Okay, so saturated fats, all the chairs are filled. They have a higher melting point because of that. They're generally in animal fats. They can store toxins. So if you're eating a saturated fat, you want to make sure it's grass-fed and not given that animal given any antibiotics. Ghee, which is clarified butter, is very high in saturated fats, and it's a good source of fat for cooking. Okay, and then monounsaturated fats. The only one we really want to cover on that is perhaps olive oil and avocados. Most people think when they use olive oil that they're getting high omega-3s, but it's not very high in omega-3s. It's high in monounsaturated fats, which means it's better for cooking than polyunsaturated. And but the reason that olive oil is so good for you is because it has other things in it. It has a lot of antioxidants in it. It has a lot of other things in it that are good for you. And you don't want it to be heated in the process of making it. So they say cold pressed, and you want it squeezed, not heated, with no solvents. So virgin olive oil, and you want it cold pressed. I've got it here. Extra virgin olive oil, cold pressed. No other solvents or heat or diluted with anything. It's mostly monounsaturated, 73% monounsaturated, 13% saturated. But it has a lot of antioxidants, oleocanthal, oleopurin, has a lot of vitamin E, vitamin K. Polyunsaturated fats, there's your omega-3s and your omega-6s. The omega-3s, salmon, fish, have a lot of omega-3s. Omega-6s, we want to try to keep those down. Soybean, corn, safflower. So salmon, trout, sardines, free-range eggs have DHA and EPA. The reason free-range eggs have it because those chickens are eating bugs and things. They're eating animals, so they get that DHA and EPA. Flaxseed and canola oil has ALA, that's a less efficient source than animal sources. Remember, the conversion rate's not very good. So once again, this is kind of a repeat. There's your omega-3 and your omega-6s. The bottom line, 4-to-1 ratio or 6-to-3 at least. Use olive oil. Avocados are good. Butter is good. It's not margarine, no margarine. Butter has a lot of butyrate in it, a short chain fatty acid, which is good for you. On the no side, trans fats, partially hydrogenated vegetable oil, very highly oxidized. Margarine, high heating. You don't want any heat. If you're heating an oil, you don't want it to smoke. So if you're going to be doing vegetables, maybe a little bit of canola oil or a little bit of coconut oil or a little bit of butter, but make sure it doesn't smoke. Okay, now we're going to move into detoxification. There are 3 phases of detoxification, phase 1, phase 2, and phase 3. And phase 1 is hydroxylation. Phase 2 is conjugation. We need amino acids for that. Phase 3 is elimination. That's basically your digestive tract as those toxins move out of your digestive tract. So we're going to go through these individually now. Phase 1, before we do that, we're going to talk about how this works. When you eat food, it doesn't go directly into your blood. Well, it does go into your bloodstream, but it goes through an artery to your liver. It goes to your liver where your liver cleans it first before it gets into your general bloodstream. And your liver takes it, cleans it, and takes those toxins and puts them into the gallbladder. And then when you eat, especially fats, your gallbladder will squirt the bile into your digestive tract, and then it goes out and it's eliminated through your feces. Or your liver can take it and put it into your, it'll put it into the digestive tract, and then your body will absorb it and it'll get excreted through your urine. Okay, so phase 1 is oxidation, reduction, and hydrolysis. There are 50 enzymes that are involved with that, more than 50 enzymes, and those enzymes reside on the membrane of the liver cells. And we talked about that, how that works, how your body makes enzymes, because those are proteins. So it's pretty amazing that on the membrane of your liver cells are encoded the instructions for making enzymes that will reduce levels of toxins in your food. So it takes those toxins and turns them into less harmful chemicals that can be excreted in the bile or the urine, or sometimes it's sent to phase 2 because it's not complete yet on the detox. Free radicals can be produced in the process, causing damage to liver cells, and antioxidants protect against damage. Alcohol, smoke, caffeine are all detoxed in phase 1. Wrong way. Okay, so the cofactors for phase 1 are tryptophan, aspartic acid, niacin, the riboflavin, magnesium, iron. The biggest one here are indoles, and indoles are from cruciferous vegetables, broccoli, cauliflower. We're going to list them later on. Onions, garlic. They're very powerful antioxidants and detoxifiers. Phase 2 is a conjugation. That means it brings together 2 different chemicals, the toxin and another chemical that makes it able to be excreted. So it makes it water soluble. And there are 4 pathways here in phase 2, 4 pathways it can go down. Glutathione, that's made from amino acids and it requires sulfur. The amino acids are cysteine, glutamate, and glycine. So that's the first way it can do it. The second way phase 2 works is with sulfate or sulfation, and that requires sulfur. And sulfur are in those cruciferous vegetables. Another way is with glycine and then glucuronidation. Glucuronidation takes carcinogens and hormones, and it's a chemical process where it attaches on another molecule to the toxin, and then that makes it water soluble so it can be excreted in the bile. So that's what glucuronidation is. Now I put down in the bottom here beta glucuronidase, and because it gets confusing between glucuronidation and beta glucuronidase. Beta glucuronidase is made by your cells, by the good bacteria in your gut, and it helps to digest carbohydrates. So when you eat good fiber, then beta glucuronidase digests that fiber. And it must be high enough to digest the carbohydrates or the fiber. But beta-glucuronidase can get too high. And if it gets too high, then what happens is it starts to detach those toxin molecules from the glucuronidation process that happened before. And so it can, for instance, if you have estrogen and you're detoxifying your estrogen, your body goes through a glucuronidation process. It takes it, puts it into the bile, gets squirted into the intestine, and then if your beta-glucuronidase is too high, your body will unconjugate it, will detach that, and then it gets absorbed back in. So now you're in a vicious cycle where your liver's detoxifying it, but it's getting undetoxified, if you will, in your colon, and it's just getting absorbed again. So we want to make sure that you have beta-glucuronidase. That's very important, but not too high, or that's a problem. And that's something that we can measure in tests to see exactly what your level of beta-glucuronidase is. Okay, glutathione is a major antioxidant in your body. It's made from 3 amino acids. It's the master detoxifier. Every cell makes glutathione. It conjugates toxins in the liver. It's a cofactor for many enzymes. It fights cancer. You need sulfur, which are high in cruciferous vegetables. And those are the other things that you need listed there in order to make glutathione efficient. And there are medical foods like powders that you can get and put in smoothies that have glutathione and give all those cofactors. That's possible to supplement with if you're having a detox issue. High levels of glucuronidase are caused by high meat consumption, high processed food consumption, high sugar, high alcohol. If you take a course of antibiotics, it can kill off the normal gut bacteria. And that causes what we call dysbiosis, which means your gut bacteria are not correct, and that can cause problems because it affects detoxification. Candida, a yeast or a bacterial overgrowth can also cause high levels of glucuronidase. This is a picture of glucuronidase, not an actual picture. It's a schematic or a model of what beta-glucuronidase looks like. Those pictures always amaze me. So that is an enzyme. So that is a protein. Your body makes that, actually the bacterial cells make that. And so that is one long chain, or that one may be 4 long chains with the different colors there. But those are amino acids strung in a row and then folded in a very specific shape. That's pretty amazing, isn't it? Okay, so phase 2 requires sulfur, requires those amino acids, and you get that sulfur from eggs, cruciferous vegetables, garlics, leeks, shallots, all good sources of sulfur, and very important for phase 2 to drink a lot of water. There's your cruciferous vegetables and some of the things that they help with. We want to really load up on cruciferous vegetables. I don't see spinach in there. Spinach would be in there, should be in there too. I'll have to add that. Okay. Phase 3, elimination through the bowel. This is, of course, very important once you get it out of the liver. And so it goes through the portal vein when you eat food from your colon to your liver. The liver detoxifies it in phase 1 and phase 2, sends it to the gallbladder, it's excreted to the small intestine, and it's possible it can be reabsorbed. Leaky gut is a problem with that because it can get reabsorbed because of leaky gut, which we're going to talk about here in a minute. And zonulin is a protein modulator of the junctions in your colon. So that's something that can be measured too. And it measures how much your gut leaks, how big those holes are in between the cells in your gut. So you need proper nutrients in order to eliminate, and that is you need good amino acids and good B vitamins. Bile viscosity, or how thick your bile is also can be an issue because bile is kind of like syrup. It can be thinner, it can be thicker. We want it thinner so that it gets squeezed out and doesn't sit in the gallbladder when your gallbladder tries to squirt it out. The gut bacteria are very important with elimination. The gut bacteria, if they're normal, will help to secrete mucin, which lubricates the inside of the colon and protects protects from bad bacteria getting in. And beta-glucuronidase, we also talked about that. Okay, so your gut biome, there are good bacteria which digest toxins and poop vitamins. They actually, in the process of digesting toxins, will make vitamins. Bad bacteria do the opposite. They digest, they eat your vitamins, and they'll poop out toxins. You need just the right amount of good bacteria. You need the right amount and a good variety. And it's also okay to have a couple of bad bacteria in there. We don't, as long as they're not the predominant. Anaerobic bacteria like lactobacillus and bifidobacter digest carbs and fiber. They produce from that acetate and butyrate and propionate, and those are short-chain fatty acids. And but the point here is that good bugs eat fiber. So what do your bacteria in your gut eat? They eat what you feed them. If you're feeding them good fiber from cruciferous vegetables and good food, good fruits and vegetables, you're gonna have good bacteria in your gut because that's what you're feeding them. If you're eating high sugar, high trans fats, and all those bad things, then you're going to have bad bugs and bad bacteria. And then we've talked about beta-gluc again. So just real quickly here, the Nature magazine had an article showing that people with low diversity of microbes have higher levels of inflammation and body fat than those with high diversity. Consumption of high fiber foods, fruits and vegetables increases microbial diversity, and these changes can be long-lasting if not permanent, and the reverse is also true. Artificial sweeteners can cause dysbiosis. So this is a model of your gut. And you can see here on top the things that stress it out: stress, toxins, food allergens, antibiotics, pathogens. Now stress, go figure there. Stress affects about everything. When you're under stress, your body turns off your digestion because it wants to devote that energy for other important things. And so that's why that happens. And so if you have a normal gut, over here you have nice tight junctions. If you have abnormal gut, then that can cause inflammation, and it can cause chemicals to leak into your bloodstream, which can cause a weakened immune system, inflammation, food sensitivities, malabsorption. And zonulin is what helps us to measure these, how healthy these are. If you have high levels of zonulin, that means that you have leaky gut. Okay, so your gut is kind of like a sieve. And when you first buy a sieve or a colander, perhaps, then it's, the holes are the right size and it works fine. You pour the noodles in there to drain your spaghetti, the water goes out, the noodles stay in. As that colander gets old, or that sieve gets old, then those holes start to get bigger. Or if it gets rusty, or then more of the noodles will escape when you try to drain the fluid from there. And that altered intestinal permeability are caused by the things on the left here: poor dietary choices, stress, infection, toxic exposure, disease, low stomach acid, and then it will cause the things on the right side here. These are some of the bacteria, and this helps to show you what in your diet will change the certain bacteria in your gut. This is a new science, and they're discovering new things every day how important your bacteria in your gut are. And they have references on the right hand side there. They're finding out all the time that the gut bacteria are affected by what you eat. Okay, clean diet 101. Left side, good things. Local, homegrown, avoid refined oils and trans fats, avoid alcohol, avoid, when we do, we can do food testing and we can find out which foods are that you're allergic to. And so you should avoid those foods. Avoid high fructose corn syrup. If you're eating the things on the right side, whole foods, colorful fruits, vegetables, leafy greens, unprocessed food, you're going to be avoiding the things on the left. If you're very sick, we want you to be gluten-free and dairy-free. We want to, because that will help to heal your gut and heal the inflammation. Okay, that's all I have for you, and thank you. And then we'll be taking some questions.